All right. We'll keep working out the kinks. Thank you. Okay, so the last one was, what was it, 9x minus 5 over x? Was that right?
Yeah.
Okay. Is this in power rule setup? No, much more complicated. But this is really simple. So when the denominator is really simple like that, I can just pull apart the fraction. So I'm going to write this as 9x over x minus 5 over x. Does that help me? Yes, because I can keep working. Let me come up here. Okay, so I'm going to move up here. So now I have f of x is 9x over x minus 5 over x. So 9x over x is 9. 5 over x, that's pretty close to power rule. How can I rewrite that?
5x to the negative 1.
Yeah, I just need to move that x to the 1 up into the numerator. Now this should look pretty easy. All right, so now the derivative of any constant is 0. Minus 5 times derivative of x to the minus 1. Negative 1 comes down in front, times x to the negative 2. So clean it up. And when you go to, we're going to get to this point, and then you may need to substitute. How many people like to think about negative exponents? Not me. I find those hard to compute with sort of naturally. So I could rewrite this with the x back in the denominator. So I could rewrite this then as 5 over x squared. This is a lot easier to plug values into. So you need to take it into the numerator to do the power rule. I recommend putting it back in the denominator for doing any computation. It just is a little bit easier to think about. All right. Okay, so let's look at some applications. There's one application that we've done already, so we're going to kind of go through that quickly. I could say, let's revisit the tangent line. Where can I write this? What do I know about the tangent line? Say again?
1 point.
Yes, it's at 1 point. So it touches the graph at 1 point, but what's important? I mean, because I could take this, that touches the graph at 1 point, but that is definitely not a tangent. So what defines
Point.
the slope? What is particular about the slope of the tangent? It's the slope of the curve at that point. The slope of the curve, the rate of change of the curve at that point is called the derivative. So for the tangent line, the slope is equal to the derivative. So tangent, slope, derivative, those all go together. Instantaneous slope. Okay, so let's do, I can then ask you to find the equation of the tangent line. Oh. Well, I made it hard, but I'm going to make it easier. Okay. For f of x equals x to the 2/3 at x equals 1. So, you need to think about, concentrate what you're trying to find. You're trying to find the equation of a tangent line, equation of a line. So what do you need for the equation of a line? A point and a slope. Okay, so you need a point and you need a slope. Do I have a point? Well, I have the x value. So can I write the y value? Yeah. What is 1 to the 2/3?
1.
1. Pretty much 1 to the anything is 1. So this is saying the cube root of 1, which is 1, and then square that, which is 1. So 1 to the anything is 1. Slope. What is the slope of the tangent line?
So you can do the x plus h.
Well, you don't have to do that.
Not yet.
We can use the power rule. But yes, it is the derivative. So the previous assignment you had to do the long-winded way. That's why I'm delaying some of those problems, because really the easy way to do it is now just to do the derivative. So the slope is equal to the derivative at 1. So the first thing I need to do is just find the derivative. Okay, so when you see slope of the tangent, when you see equation of the tangent line, you know you're looking for a point and a slope is the derivative. Okay, so what is the derivative of this?
2/3 x to the negative
2/3 x to the minus 1/3. So it's just a power rule. Bring the exponent down in front, bump the exponent down by 1. So f prime of 1 is 2/3 times 1 to the anything is 1. So now what do I have? I have a slope and a point. So the equation of the line writes itself. Okay, so just remember, if you're looking for the tangent line, the equation of the tangent line, you still need a point and a slope. You have the point, the slope is the derivative. So slope and derivative and tangent, they all go together. So I would have 1 x minus 1 equals 2/3 x minus 1, 2/3 x minus 2/3 plus 1. So same old equation of the line, but the slope, I find these slopes even easier to find than actually doing the slope between 2 points. I think sometimes these are easier to do. Okay, so here's another question. So one question is find the equation of the tangent line. Another question is, where is the tangent line horizontal? So let's see, what can I erase? I'm going to erase this and write question B. Where is the tangent line horizontal? A bad example for that. Okay, what does that mean?
Word equals 0.
Yes, tangent line horizontal. Horizontal means 0 slope. Tangent line means the slope equals the derivative. So put those together and what do you get? Where is the derivative equal to 0? Okay, so when I ask where is the tangent line horizontal, it's saying where is the slope of the curve equal to 0. So let's find that. Here's this. Remember how I said this is a little bit easier to deal with if we put it back in the denominator, so let's do that. 2 over 3x to the 1/3. Is that ever 0? Can you think of a single x value you can put in there to make that 0? Well, set it equal to 0. Multiply both sides by that, right? So multiply, so I get 2 equals 0 times 3x to the 1/3, so 2 equals 0. So the answer to this is, does that exist in your world? No. So if you get something like this, which you know to factually be wrong, this can never be true, then the answer is, it is never equal to 0. There is no answer. So the answer to this one is never, because I picked an example on the fly, instead of going by the one I had it listed in my notes. So, is it horizontal? Set the derivative equal to 0 and solve for it. So let's do another one where we actually get one that makes sense. Right here, I'm going to combine a little bit into work problems, so I'm going to do this. I'm going to say, if the position of a particle, position of anything, particle, car, whatever, is described this way. When, make that a minus, when is the instantaneous velocity or instantaneous speed 0. The answer to a when or a where question is, that's an x value, or in this case, a t value. So this is, if I say what is the instantaneous velocity, then the velocity is the answer. If I say when or where, in this case when, it's a t answer. So this says I'm looking for t. It says find t. What do I know about finding t? I know that the instantaneous velocity is 0, so something equals 0. What is instantaneous velocity? How does that compare to position? How does velocity compare to position? Say again?
Rate of change.
Yes, it's rate of change. So velocity is rate of change. So I now have instantaneous rate of change. What is rate of change? Slope, instantaneous slope. What's instantaneous slope? Derivative. So these are equivalent questions. When is the tangent line horizontal? It says when is the derivative 0? When is the instantaneous rate of change equal to 0 is the same question. When is the derivative 0? Okay. So what that says is set this up. You now have your, this says find t that makes the derivative 0. So what is the derivative? Let's go ahead and write that down. The derivative of t cubed is 3t squared minus, what's the derivative of 2t squared?
4t.
2 times 2t, so 4t. And set it equal to 0. Is this an easy one to solve for 0?
Yeah.
Yeah. That's a polynomial equation. How do we solve polynomial equations? Set equal to 0. Factor them. So what comes out of both? T. 3t minus 4. And now I just solve. So I'm going to get t equals 0 or 4/3. So instantaneous velocity is instantaneous slope, is instantaneous rate of change, is derivative, is tangent line, all of those things wrapped together. So when is an x or t, in this case, answer? So here's my answer. So the thing that you're doing when you're pulling apart these sentences, pay attention to what you're trying to find, and then pay attention to your condition. And just start writing it down. And it's okay to write everything down. Don't feel like you have to jump to the answer. Write what you know, and then use that to find something else you know, and use that to find something else you know, until you get to a point where there's some math to do. Okay, so don't worry about trying to jump to the answer the first time. The problems are going to start to get complicated enough that you just need to just lay out some steps. Just keep working through it. Okay, one more. Is this okay? This one's a little bit of a stretch. The one we're going to look at next is a word problem. It's actually number 90 on page 155. And it says, a company's total sales in millions of dollars in T months. The total sales.
What was the page again?
155, number 90. Total sales, millions of dollars in T months is given by this. 0.015 t to the fourth plus 0.4 t cubed plus 3.4 t squared plus 10t minus 3. So the instructions say find the derivative find the actual sales value at 4 months and the derivative at 4 months. And interpret. So remember, there's a difference between find and interpret. Find means just list the number. Interpret says, what does that mean? So it's a number. And tell me about that. Okay, so just remember the difference between find or identify and interpret or explain. Okay, so this derivative, is this actually fairly easy to do? I mean, some of the numbers aren't pretty, but it's pretty straightforward. There's nothing really strange. So this would be 0.06. I'm just going to kind of blast through it. 0.015 times 4 plus 3 times 0.4 plus 2 times 3.4 plus what's the derivative of 10t? Just 10? Because when I bump this is an exponent of 1, if I bump that down, I get t to the 0. Anything to the 0 is 1. And the derivative of 3 is?
0.
0. Right, so this is my derivative. So now I'm asked to find s of 4 and s prime of 4. Is that hard to do? I'm just plugging in the appropriate equation. So why doesn't, like this half of the room do s and this half of the room do s prime? Because I don't know what the answer is. So if you guys would actually compute this so that we can quickly interpret that and then run off to our minute to win it. So somebody put in 4 into this first equation on this side, and on this side put 4 into the derivative equation. Because remember, that's what this means. S of 4 just means plug the 4 in for t. S prime of 4 just means plug the 4 in for t. While you're doing that, I'm just going to start passing this out. I'll start calling that yet, but let's finish this up. So did anybody get an answer?
2.24 for 4 times.
Say again. You got what?
60.24.
Yeah.
60.24, anyone get that?
Yeah.
All right. So 60.24 for S prime of 4, 60.24. Anybody do this one, S of 4?
60.24. Oh, no.
Which one? This one? Did
There's
anybody
the
do,
bottom one. Yeah,
did
this-
anyone do the top one?
I got 60.24
For this one?
for the.
This one. Did anyone do this one?
For the middle one.
60.24.
Did anyone do this top one? Yes, what'd you get?
I got 120.84.
120.84. What do those numbers mean? What is S? S is millions of dollars. So this is millions. What about this one? What about this one?
So how much it increases over the months?
Yeah, this is, so let's think about S prime. We can really write that ds dt. When you write it that way, the units become really clear. Dollars per month. Okay, so this is millions of dollars per month. So word problems, word answers. Fine. So what is the interpretation? At 4 months, the sales are this, and they are increasing at this rate. If this were negative, they would be decreasing. So this is the present sales increasing by. Okay, go ahead and do the minute to win it. And just turn it in on your way out.
We didn't have
I know, I'm coming. Okay.